Hey folks, Todd Coburn here, the Aerospace Structure Series. This little lecture is on MATLAB, getting started. Really, I'm designing this specifically for my composites class, which could also be used for my finite element class, but can also be used for a number of other classes or analyses that somebody might need. So we're going to cover how to get started punching the buttons, but we're also going to focus on some matrix methods since we need these in these classes. So it's kind of a getting started video, but it's kind of focused on preparing for matrix operations. Let's see how it works. I'm going to go through some simple slides first, then we'll pull up MATLAB and play around with it so you can see button by button what you need to do. So if you're starting MATLAB, first you need to obviously get a copy of MATLAB. Students can often get it for free. Industry professionals are going to have to pay, usually. There are also free versions of other programs that run just like MATLAB. So you're going to find a computer with MATLAB on it, and from the Start menu, you're going to launch MATLAB. And then you're going to generally get one or two windows. Usually if it's the first time on, you're going to get a single window, and it's going to look something like this. This has a number of little sub-windows. The main one we're going to focus on here is the command window. As you become more expert in this, you can learn to use the other windows, but I'm going to focus on what you absolutely need. That's the command window. That's right here in the middle. You can actually work on this just like a scratch pad, doing your work right here. The problem is it's not really being saved anything but the short-term memory. So the best way to use MATLAB is to always write programs. They call them scripts. It's just like a text file, a little command, just like English. So we're going to write scripts. Even if you want to do something simple, the chances are you're going to want to do it again and again, and you might want to make it more and more complicated, and you might want to remember what the keystrokes were, and that's where programming is so powerful and important. Now, the problem is once you get going, you start saving this and that, and you get the fever of the power of a tool like this. You're going to get so many programs, you're not going to be able to find your program. You're thinking in the back of your mind, oh, I know I did this before, but I can't think of where it was, and you're going to be searching through and getting more and more frustrated. So what you need is a good naming convention and a folder system so you can keep track of your programs and precisely what they do. And different variants of the programs need to be identified carefully so you can keep track of them. We'll talk more about that perhaps on later videos. For now, we just opened the stupid thing and we got this window. We're going to focus on the command window because that's where we're going to write. Now, what we're also going to want to do to make these programs is we're going to want to open a script window. And when you do that, you're going to get this editor. You can do that by punching this little new button. See the little plus button? If you already have a program, you can use the open button to open your program, or you can hit the new button. It'll come up with a new program. You'll notice here in my editor window, the rightmost window there, I've got three things. I've got two titled and one untitled program already there and ready to go. So we can actually write nearly anything in the command window. Let's jump into the command window and look at how that works. Like if we write 2 plus 2 in the command window, it's going to write immediately. As soon as we hit enter, it's going to give the answer 4. And then it gives it the double caret sign that shows that it's ready for more. It's like your dog. You throw the ball. The dog gets the ball. It comes running back. It drops the ball and it's waiting. It's got its tongue out and it's waiting for the next ball throw, and that's what MATLAB is. It's like your puppy who is waiting to go retrieve the ball for you. Just type a command and it will do it. If we type x equals 2, it's just going to x equals 2, enter. It's going to tell us, you just told me x equals 2. Woohoo, give me another ball. And that's how it works. If we type y equals x plus 3, it's going to do y equals. Now what it's going to do here is it already knows that you already assigned x was equal to 2. So now it's going to add 3 to that, and it reports that y is now 5. Now to make a matrix or a vector, you're going to enclose that. There are actually a number of ways. You can use parentheses and you can use brackets. But the brackets, the square bracket, is the key for matrices. So if we type z equals open bracket x comma y close bracket, it already knows that x is 2. It already figured out that y equals 5, and it now is going to create a vector, which is a matrix, a 1 row by 2 element matrix with the elements 2, 5. Now it's not going to repeat those brackets for you. It's just going to throw out that array of numbers 2, 5, but it has them linked together in a matrix Z. Now if you ever get stuck, you can type help and then the command name, like help help add, help inverse, help this. If you think it can be done, you can write that name, and if it actually happens to be a command, then MATLAB will report all kinds of information. If you just write help and enter, it will give you a list of a bunch of commands. And MATLAB does have a lot of good tools, and this can sometimes help you to find things that you need. And you can click on those tools, and here's what some of those look like. Okay? So let's go ahead and get ready to start our own first program. What we would do is we click on that little plus button to open a new script, and then the editor window is going to come up, and what we're going to do is save that. And I'm going to show you how to do this in MATLAB itself in a moment. We're going to want to give it a file name. So a lot of times if you're a student, you're going to want to name it by your class, like ME499 or Arrow 4360. This is my nomenclature. I recommend that if you're, so for my students, when they're doing programming in my classes, they need to put the title, which is usually the title of the class, Arrow 4360, underscore with their, usually I'll have their name, last name, first name, and then whatever that program does. So that way I can differentiate the different students' programs. You can make that whatever you want. Now you're going to, you're going to make a couple commands. The function command should go at the top of every program. Now you can actually get away with a lot of sloppiness with MATLAB. MATLAB is very powerful, but you're going to want to get in the habit of always calling your function, calling out the function command, and then the name, and then open and close parentheses. Later we can learn how to use arguments going to and from the program to do more powerful things. Right now, just type function space and then whatever your file name is. In this case, my file name is Arrow 4360 underscore P1 underscore Coburn underscore Todd, open parenthesis, close parenthesis. Now the thing is, MATLAB doesn't like dashes in the title, but underscores are fine, okay? Now, MATLAB uses the percentage sign as a comment. Nastran uses a dollar sign. Different programs use different things. Some programs use a little dash or a quote, single quote. MATLAB uses a percentage sign. So I recommend at the top of all your programs, right after the function line, you give yourself credit for being the creator with your name and with the date. And you'll see that I did that here. MATLAB is just going to skip right over those comments because those are comments. You can always also use dollar signs, percentage symbols, to augment your code to define what is going on to make it easier for you to understand later. So if we typed in our new program stress equals 7,500, that's going to set the variable named stress with the value 75000. That's actually 75,000, right? This little percentage sign means it's ignoring everything right. That's now a comment, and I'm just reminding myself that I entered that in PSI units. That's completely optional. Then the next line, I put E equals 10.6 E6. What that does is that defines that number that I put in, which is 10.6 million, and it's going to store it in the variable E. And I'm reminding myself that I put that also in PSI. Then if I type strain equals stress over E, the strain is a new variable name. Stress is a variable name we already assigned to 75,000. E is a variable name we assigned to 10 million, 10.6 million. And this is going to spit out the strain based on for that stress and that modulus. That's a pretty simple program, one of the simplest programs we can write, and that will report back what that number is. Now, if we want to make our output fancier, we can use the fprint command. So look at this. You've already learned a couple commands. You learned the function command. That's how you're identifying your program. You learned how to assign variables, and now you're going to learn how to write out with a formatted write. And the way you do that is you write this word fprintf. That is a command in MATLAB that says, I'm going to use a formatted print. Everything you're going to need to tell it is going to go between two parentheses. And there are going to be other parentheses in there too. You're going to tell it where to write it. Now, what you can do is, if you're a good programmer, if you programmed before, you know about assigning variable numbers to different input-output devices like a printer or a file name or whatever. We're just going to put, right after the open parenthesis, just put a 1. That identifies the screen, or actually the command window for MATLAB. And that means it's going to write it to the screen. Later, as you get better, you can learn to change that and send that off into files. Right now, we'll just give it 1, comma, and then between single quotes, we're going to put everything we want to say. Like we want it to say, the strain is equal to stress divided by E, right? This is telling the user what it is we're doing. So these single quotes define the string that it's going to print to the screen. Now, whenever MATLAB is reading inside this little string for things it's going to write to the string, when it sees a command sequence, it's like let's say we have Superman. He's got a little button on his chin. You push the button and he goes rocket, right? That's what that little button or those command sequences does. When MATLAB sees a /n, it sees that slash and thinks, ooh, this is a special command. /n is a special command. It means go to the new line. So it's not going to write /n to the screen. Instead, it recognizes this is a command. I'm going to go to a new line instead of writing on the back of whatever line I'm on. Then it's going to write all the characters defined. So it's going to write strain equals stress over E equals. And then when it sees that parenthesis, now, that percentage sign. Now remember, I told you that the percentage sign is actually a comment, but that's only when it's out floating in the open stream in MATLAB. When it's encountered inside these single quotes, it actually is a command sequence that says that we've got a formatted number coming. And the 8.4, the way that works is you can use integers and fixed numbers, real numbers. We're going to use that parenthesis, that percentage sign, and then at the back of that you're going to see the little F is telling it what kind of number you're going to have, which means you're going to have a real number, which means you can have decimal places. And then between those, what it's looking for is telling you what it is. Okay? Stand by, I'm going to pick up this call. So when MATLAB sees a percentage sign within those little single quotes, it sees a command sequence. Between the percentage sign and the F, it's going to be looking for how many total digits is this number going to be, and this means 8. And then there's a decimal place. How many digits do I want to see after the decimal place? So if you had a 5.4, there would be 5 total decimal places, and 4 of them would be to the right of the decimal place. That means that works for small numbers. If the number is bigger than a single digit before the decimal, it's going to blow up and not write the number. This one says we need 8 characters for writing the number, and half of them, 4 of them, will be after the decimal place. And then, since the F ends that little command sequence, it goes back to writing whatever it sees. So it's going to put it blank. It's going to put inches per inch. And then it comes up to /n. It's going to go to the new line. And then it's going to write out the string. Whatever is the value. See that little comma? We got those 2 quotes. That's everything that's being written between. The comma says, okay, that's the end of that piece of information. We have the 1, which tells it where's it going to write the information. We've got those quotes that tells what it's going to write, and then after the last comma, it's got another piece of information, and that is the magnitude, whatever is in the variable name strain. Strain has already been defined as a number that we just calculated, so now it's going to put that strain. Now what happens is MATLAB writes the string. It goes to the new line. It does it to the 1, which is the command window. It's going to go to a new line. It's going to start writing strain equals stress over E equals. And then it sees, I'm going to put a number. But it doesn't know what number to put. So it gets ready to put that number. And it's going to look off to the right beyond the comma to see what it's going to put there. And it's going to put the first thing it finds, and that's the strain value. Whatever that value is, it's going to dump it using the format between the percentage sign and the F. When it gets done writing that number, it goes back to writing whatever it was writing. The space, inches per inch, goes to a new line, done. That's how it works. Okay? This is actually a little bit advanced. You could have just ended the program in the last line and you just get ugly output, which accomplishes the same purpose. But if you start practicing with quality output that tells precisely what you're doing in a formatted way that's understandable, your programming will become gold much, much faster. And you will become confident, and everybody else will be impressed, and you're going to earn the dollars that eventually your company is going to be paying you. We're then going to save that program by pressing the save button. Actually, the way MATLAB works, you can just run the program. It will save it itself. But it's a good habit to save it frequently. We then can look at the main program window to see what happens. Now what this is doing, this is teaching you about the diary command, and this is what this is doing, the diary command. If we had written that next in this format, that's going to name a file with this name. This is one way of spitting your output off to another file. So we're going to go ahead and jump over this. This is a little more advanced. You don't really need to do this. Another way you can do this is once you've saved your program, you can just copy and paste what is in the command window to a file. That's a lot quicker and it works fine. Okay, so we're going to jump over this diary stuff. I should have taken this out of this elementary video. All right, so let's look at some practice here. Let's say we need to multiply two matrices A and B. So A times B, right? That's a pretty simple thing to do. We're going to be multiplying row times column, and so on, as we learned in matrix algebra, but it takes time. Wouldn't it be easier to just define each matrix and then just say A times B and let MATLAB do the work? I mean, throw that ball and let MATLAB fetch it. That's what we're going to do. So let's say we make our first matrix. The way you call out a matrix in MATLAB is you're going to give it a name. We're going to call this one A. It's a capital A, right? There's a difference between capitals and lowercase in MATLAB, so it gives us more options. Equals, and then we're going to call out a matrix. So the open bracket defines we're a matrix, and you can just space those out with a space between each value, 1 space, 2 space, 3, close bracket. This says, since those were spaces, and I believe a comma, we can try this later, a comma I believe works fine too. What this is going to do is give you a vector, 1, 2, 3, which is a matrix which has 1 row, 3 columns. You hit enter, and MATLAB repeats it to the screen, just like your dog fetching it, and brings it right back at your feet. MATLAB repeats what it found. We're then going to put in the second matrix. Now this one, we're going to multiply these two together. You can't multiply two row matrices together. It needs to be a row times a column, same number of elements. So we need to call out a column matrix. One way to do that, so with MATLAB, to call out the elements, the different columns in a row, we just need a space or a comma. For a column matrix, to go to the next row, what we need is a semicolon. So we're going to go open bracket, 10, semicolon, says next row, 20, semicolon means next row, 30, close bracket, enter, and MATLAB repeats back. You'll notice MATLAB wrote the row vector like this and the column vector like this, as we would expect to see. It just doesn't put the little braces on the side of it. Now that we have the two defined, we can multiply them together. We could have just typed A times B, and it would spit out the answer. Or we can define what we want to call that so we can use it later. C equals A times B. And then MATLAB says, okay, I got it. C equals 140. Got that? So if we have, once again, if we have A equals 1, 2, 3, and B equals 1, 2, 3, 10, 20, 30. Now look at this. Now let's say we've got the same A matrix, but we call out a different B matrix. You'll notice the two B matrices are identical, but this time we made B a row matrix. But the multiplication of two row matrices is not defined because we need to have a column and a row for every column when we're multiplying them together. If we're multiplying a row times a column vector, we need to have as many rows in the column matrix as we have columns in the row matrix, because it's going to be bang, bang, bang when it does that multiplication. This is not defined. MATLAB says, but you guys don't know what you're doing. It's like a dog when you do a fake throw and you don't actually release the ball, and he does this and he looks a little confused. That's what MATLAB is doing here. Now, if we had instead say, oh yeah, I meant to put in a column matrix, all we need to do is transpose that B matrix and that will make it a column matrix. The way MATLAB does that is not with a T, but with a prime. So C equals, we type C equals A times B prime. That prime on the B means use the transpose of it, and now we have a defined thing and we get the same result as we did before. So B prime, if we just write B prime, it's going to say, well, B is still 10, 20, 30 in a row matrix. And now if we write B prime, it's going to tell us what that is. If we wrote B, it'd give us the row matrix back again. Okay? Okay, so there's another way. Let's see. So let's say we have A, the same matrix. We have B, the same matrix. Okay, now before we just typed A times B. What that tells MATLAB is it's going to multiply these two matrices together using standard matrix notation. Another way to multiply these together is to do it like this. See, we have an A dot, or period, times B. Whenever MATLAB sees the period times button, period asterisk, it says, oh, this person doesn't want to do a matrix multiplication. They want to do a dot product. That's the same as a dot product where it multiplies all the elements together. So what that's going to do is take the first element of A, again, multiplied by the first element of B. The second element of A, multiplied by the second element of B, and so on. And the answer is then obviously 10, 40, 90. Okay? So here's A again. B, if B is B prime, there's B prime. If we do A dot times B prime, it can't do it because you'll notice A has a row with 3 columns. B has a column with 3 rows, so it doesn't have, the only element that's the same in these matrices that can be multi-dot product together is the 1 and the 10. Everything else doesn't align. It can't, it's not defined. So once again, with a matrix multiplication, you're going to need to have, the first one has to have as many columns as you have rows in the vector that you're multiplying against. And when you're doing a dot product, those matrices are going to have the same size. Okay? All right, let's say we have a matrix A. Looks like here. Now take a look here. This is a full matrix. What we have is 25, 5, 1. That's our first row because then we have a semicolon. And the next row we have 64, 8, 1. Great. Semicolon. Next row 144, 12, 1. Close that puppy. That defines a 3 by 3 matrix. MATLAB repeats it to the screen in its relative position. Let's say we have a matrix B, called out this way. If we wish to solve this system of equations, AX equals B. Now, if we had A and X, all we need to do is do a matrix multiplication. But if we have A and B, then we need to actually solve the system of equations, which means X is equal to A to the negative 1, or the inverse of A, times B. That means we need to take the inverse. That was a hassle back in linear algebra, but we can do it easily in MATLAB. A couple different ways. Now, if you want to know if an inverse exists, you can write just INV, open parenthesis, of A is that matrix, close parenthesis, and if it comes up with a number, it exists. Woohoo! If it doesn't come up with a number, it doesn't exist. Actually, MATLAB will sometimes come up with no number for something that does exist if it just doesn't have a smart enough tool to solve it. Remember, some inverses are easier to calculate than others. Some advanced techniques have been figured out to be more robust in solving systems, equations, and inverses and things like that. Anyways, so if it exists, if MATLAB can calculate it, it will do so. So we can just say X equals inverse of A times B. That's one way of solving this. We can also just use X equals A, and now we're going to use that backslash key, not the slash, but the backslash, and that says divide B, A into B, which is actually solving the system equations. You'll notice we get the exact same number. Okay? All right. Now, when you save your program, you're going to need, it's going to tell you where do you want me to save it. And it's going to say, well, I want to put it in one place. Is that where you want to put it? If you actually go looking for your program, pull up a program it doesn't know what it is, you're going to need to set it in the path, which means the search path of window folders where it can find your program. The easiest way to do this is just to hit the save button from MATLAB, and it will say, hey, look, this is not in the path, and you can actually put that in. That's what this slide is talking about, and you may need administrative privileges to change the path permanently on your version of MATLAB. But if you want to know, well, what path is MATLAB already looking for, you can just type path, enter, and it will spit out all the paths that MATLAB is going to use, like in this particular case. If you want to add a path, you can do that within the MATLAB commands, or you can just go and when you try and run that program, it will allow you to do that at that time. Okay? So that is some basic tools and techniques. So that's how we use MATLAB. I'm going to go ahead and create another little short video and make it separate, I think, in order to play